Hello, Matt Davis here with more homework quiz help. This one comes from section 10.2. A student suspects that a die is not fair. To test her suspicions, she rolls the die 150 times and gets the following frequencies for each of the numbers on the die. Calculate the value of the test stat, calculate the p-value for the test. All right, so we are going to go ahead and do that, but first we're going to make a couple changes in the interest of giving help rather than answers. So we're going to change our sample size from 150 rolls to 156 rolls of the dice. And we're going to do that here by just adding 1 to every count. So we're going to make all of these 1 higher. So we'll get all those adjusted and then we'll get to work. All right, so this is a chi-squared goodness of fit test where HO would be something along the lines of the distribution of the numbers are the same as they would be on a fair die, and the alternative would be that they're not the same as they would be on a fair die. And we would have some alpha given to us, and then we would move on to a step 3 where we would calculate the test statistic. And to do a step 3, we generally need to make a table. So I already kind of set that table up down here. We're just going to go ahead and drag that table up there now and get to work on it. So let's see, right about there, ought to do it. Okay, so I've entered the different numbers for the dice, 1 through 6. I've entered the observed frequencies, which are the frequencies that came from the sample. And then we want to come up with a value of pi for each category and then calculate expected frequencies and then go on from there to our mini z-scores, which are the O minus e squares over e, sum those up to get our test stat. So for pi, usually, or at least a lot of times, they've given us a chart that has percentages in it for each category, and we just convert those to a decimal. That did not happen here. So when they don't give you those values of pi, you're supposed to think about what HO said. And HO in this case is, the short version is the die is fair. And if the die is fair, then each number should come up 1/6 of the time. So the values of pi would be 1/6 for each number. So when there's no percentages given, you should think if HO is true, what would be the probability for each number on the die or each category in what you're doing. And in this case, for a fair die, that would be a 1/6 probability for each one. So then if we wanted to fill in the expected frequency to go with this right here, so we'll end up putting that right there, what would we do? E would be our value of n, which was 156, and we would multiply that times 1/6, and if you do that, you get 26. So our expected frequency for the first one is 26. Now notice that the number 31, that O for the number 1, doesn't factor into that. All that factors into that is the sample size and the value of p. The sample size is 156 for every category, and the probability is 1/6 for every category, which means that we get a 26 in every single one of these spots. And if you add those all together, here you get 156, and if you add all the O's together, you get 156, and you should check those to make sure they match. All right, so now we're on our way to doing mini z-scores. If we wanted to keep working on row 1 and get the mini z-score right here for the first one, then we would want to do O minus e squared over e. So O for that row is 31, minus e is 26. Square that and divide by e, which is 26. And if you do that on the calculator, you need to make sure you put parentheses around the top. So let's look at that together. So we'd want 31 minus 26 and the parentheses and square to make sure the subtraction happens before the division. And then make sure you divide by e, not o, so by the 26. And to 3 decimals, which is what we would put for a z-score, so that's what we'll do for the mini z also, we get 0.961. But the 1's followed by a 5, so we'll round the 1 up to a 2 and go with 0.962. So our first mini z-score right here, 0.962. 0.962. And then we could repeat that 5 more times using the different values of O. These values of O could then get used in place of that 31 one at a time. If we don't want to do it one at a time, then we can use our calculator to speed this up by taking the values of O and putting them in L1. We can put the values of PI in L2, use those to get the values of E in L3, and then go on to do L4 by doing L1, which is O, minus the E values, which are in L3 squared, divided by L3. And if we do that, we'll get all the mini z-scores at once. So let me show you what that looks like. So I press Stat and Edit, and I've already put in the values of O and PI into L2. So now make sure you highlight L3, not the first entry in L3, but up top, the title. And then we will type N times PI. N was 156 times the values of PI, which I've stored into L2. And when I do that, I get 26 for each one of them, just like we wrote down a moment ago. And we can arrow over, highlight the title for L4, and say we want O's, which are in L1, minus the values of E, which are now in L3, and parenthesis and square to make sure the subtraction happens before division, and divide by the values of E, which are in L3. We do that, our first one is 0.962, and then we have the other 5, and we can copy those down. Instead of copying where you see the yellow highlighting, if you look down below the table, you also see the highlighted number written again with more decimals. It's important to copy it there, otherwise you can get a rounding error build up to cause some errors, especially on the TID4 as opposed to this screen. All right, so let's go write down those numbers we just got. So for 2, we get 0.346, and then 3.115, 0.346, 0.154, and 1.385. And the total of all those mini z-scores will be our test statistic. And we could just add those 6 numbers we've just written down up. The other option is have the calculator do it for us. So if we go back to the home screen, above the stat key it says list, so in orange. So if I hit second and then list, I get some options I can do with list. On the right side column you have math, so I'm going to press the math button, and the 5th row down is a sum, and so I can take the sum of what is in L4 by hitting second L4, and that'll tell me the total there, 6.307, but followed by a 6, so we would round up and have 6.308 for our test stat. So we'll write that down, 6.308, and that is our chi-squared test stat, and that is what they wanted for our first question. So get the test stat, round that to 3 decimal places. We have that right here. If you add the individual numbers, you can get a different last digit on your test stat. I'll accept either one, but it's more accurate if you use the sum from the unrounded numbers in the calculator, so I would encourage you to do that. But if you round these numbers here individually and then add them up, I will take it even if your last digit is off by 1 or 2. All right, so there's the test stat part. Now we want the p-value part, which is faster. Get the p-value, round it to 4 decimal places. So it's a chi-squared test statistic. So for our p-value step, we're going to look at the area underneath a chi-squared curve. Chi-squared curves are right skewed and start at the number 0. And chi-squared curves like a T have a DF. That DF is the number of row categories minus 1. Number of row categories we have here, 1, 2, 3, 4, 5, 6. So the DF would be 6 minus 1, or 5. Because it's right skewed, the mean will be just to the right of the peak. For chi-squared curves, the mean and the DF are the same, which is unusual, but it's true for these. So we know where 5 is, we know where 0 is, so that helps us have an idea of where 6.308 would be. That would be just a little bit past the 5, so somewhere in this neighborhood, 6.308. And all chi-squared curves are right-tailed. all chi-squared tests are right-tailed, I should say. So that area to the right is going to be our p-value. So that's what we need to calculate. So our p-value is that area to the right of our test stat. That'll come from using chi-squared CDF. Sometimes people accidentally use TCDF, which will give you a very different answer, so you got to be real careful with that. 6.308 to infinity, because we're going forever to the right, and with 5 degrees of freedom. So just need to go calculate that, and we'll be all done with this one. So let's hop over on the calculator one more time. Go into the distribution menu. Looks like I misclicked there. So second distribution, avoiding row 6. This is not a T curve that we want. It's row 8 chi-squared CDF. And our test stat goes first because it's our lower boundary. So 6.308. No right-hand boundary. We're going forever to the right. So alpha I for infinity. And then with 5 degrees of freedom, and we get 0.2773, but the 3 is followed by a 9, so we'll round the 3 up to a 4. 0.2774 is going to be our p-value. So we could box that piece. It's not the answer to the overall hypothesis test, but it is the answer to the p-value question, which is one of the ones that we're presenting here. So we got our two pieces. In yellow, we have our test stat. In green, we have our p-value. Standard rounding rules, so 3 decimals for the test stat, 4 for the p-value. Some places that this can go wrong, sometimes when people don't have the values of p or pi, they kind of panic and they try and use O to calculate the values of pi. And if you use your O to try and get your expecteds, it's not going to work. So when the values of pi are missing, you don't calculate them using observed. You calculate them thinking if HO is true, what would the probability be for each of these categories, and that's what you fill in. On a lot of problems, it's the same, not always, but for a fair die, all 6 sides would be equally likely, so that's where we come up with the 1/6. Then it is better to use a fraction than a decimal, because a decimal will have rounding error in it, and the fraction will not. Make sure you're using chi-squared CDF and not TCDF. Seeing the DF around makes it tempting to use the T because we're so used to that from chapter 9. But it is chi-squared CDF. It is a chi-squared test stat, so be careful with that. And then it is a right-tailed test, so no doubling of the p-value or anything like that. All right, I hope somewhere in there you saw the part that was giving you trouble and that this helped you clear that up. So good luck to you as you head back to the quiz.